Hello and welcome. My name is Jonathan Crabtree, and I would like to start by acknowledging all the people who are currently suffering because of lockdown, because of anxiety, because of ill health, because of death in the families brought about by the coronavirus. I would also like to pay my respects to the First Nation people of Australia, upon whose land I am making this presentation today. Let me begin by pointing out that I have some background slides and a video at the address on your screen, which covers, amongst other things, how India's zero concept never made it to the West. So this presentation is also dedicated to the gurus and rishis of ancient Bharat, India, whose wonderful system of mathematics never made it to Europe or to classrooms today. And in this talk on the topic of mathematics foundations, I'll just be touching on some of the ideas that have emerged from my research over the past 38 years. The background presentation also mentions why primary school teachers should make a switch from arithmoi to arithmos. See the presentation to understand what I mean. Everyone knew the universe was expanding, yet gravity slowed this expansion. Eventually, the universe would contract under the force of gravity, and the universe would end in a big crunch, a fireball. Yet 3 astronomers had a problem. Their data said the expansion of the universe was speeding up. This went against everything known. So Dr. Adam Rees wrote, "Approach these results not with your heart or head, but with your eyes. We are observers after all." And the mathematical ideas that I'm going to be touching on today originate not from the philosophers of ancient Greece, Plato, Aristotle, and so on, but from the astronomers of ancient India. So by believing their eyes, they won Nobel Prizes for the discovery of the accelerating expansion of the universe through observations of distant supernovae. So here we've got The Art of Calculation in 4 books by Cuthbert Tunstall, which was England's first ever mathematics book. This is the 500th year that it's been out. I'm suggesting that elementary math pedagogies have been disconnected from science since 1522. For the best part of 500 years. So to understand the foundations of primary level mathematics, seeing is believing. And I've been rebuilding elementary maths foundations from zero since 1983. I first noticed problems in the foundations of mathematics in 1968. So that's a long time to be thinking about elementary arithmetic. And in that newspaper report, you can see that I was quoted, "I hope to change the way the Western world teaches maths." So here I am at the Australian Association of Mathematics Teachers conference to discuss how science simplifies and supercharges primary level mathematics learning and teaching. Science has units of quantity, so let mathematics also have units of quantity. As mentioned in my background paper, arithmos is the mathematics of number associated with units of quantity. And yet too much of the mathematics taught today is arithmoi, which is numbers which are separated from units of quantity. So in our closed system, we're going to begin with 0 cubes on ocean level 0. The equal and opposite quantities will sum to 0. Either 1 cubic meter of liquid or 1 cubic meter of solid can be considered a primary unit of count or measure. It doesn't matter what we say is positive or what we say is negative. The laws and the rules of our empirical mathematics foundations remain consistent. So let's imagine that we added solid cubes to ocean level 0. Did the ocean rise or fall? Well, neither, because every action has an equal and opposite reaction. Here we added a solid cube, and here we subtracted a solid cube. Or alternatively, here we subtracted a liquid cube, and here we added a liquid cube in that hole. So you can start to see the physical properties of nature have a wonderful symmetry that appears if we open our eyes to observe it. So Newton's third law is every action has an equal and opposite reaction, and yet I'm suggesting to you, if we look closely at the mathematics that we should be teaching, every operation has an equal and opposite operation, especially if we are recognizing that quantities obey the law of conservation of mass. We are talking about science after all. So 0 here has been symmetrically split into equal and opposite quantities. They're equal and opposite, they're equal in magnitude, and they're opposite in the quantity, because if we bring them two together, they will cancel each other out. So the equal and opposite quantities all sum to 0. So here we've got the solid cubes adjacent to the holes. And so what would happen is if we combine the two together, we've got 10 positives in the cubes of the solids, we've got 10 negatives in the cubes of the liquid in those black holes. So if we bring them two together, they will again sum to 0. And we have 0 cubes of solids, and we have 0 cubes of liquids. So if liquid is positive, then solid is negative, as they cancel each other out in our closed system. And vice versa. If liquid is negative, then solid is positive. It's an arbitrary choice. So we let the solid cubes in our model be positive and the liquid cubes be negative. So let's start to count the two opposing quantities. On the right, we have solid cubes. On the left, we have liquid cubes. And we can see that we have the least quantity of cubes we can have is 0 cubes. And neither negative cubes nor positive cubes are less than 0. I could easily say 2 negatives are greater than 0 negatives, just as 2 positives are greater than 0 positives. In our closed system, they have equal yet opposing properties. Here, let's go back to ancient China, and I'll just mention a tiny part of this quote. In it, I observed the division between the dual natures of yin and yang, the negative and positive aspects, which sum up the fundamentals of mathematics. Now, in ancient China's rod numeral arithmetic, they had negatives and they had positives, consistent with yin and yang, and they were equal and opposite, and they would cancel each other out. Yet they were just simply resulting in a blank space on the counting board. The Chinese didn't have as 0 for about another 1,000 years. So here, let's look at what I call the basic lines, or the B lines of Brahmagupta. And he is the guru, he is the genius of mathematics who gave us a system. He wrote all the laws of negative quantities, positive quantities, and 0 with the 4 basic operations, and yet those laws, those 18 Sutras of Symmetry, failed to be transmitted to the West today. But Brahmagupta defined 0 as when the number of positive and negative quantities are equal, the sum is 0. We can see that the least quantity we can have is 0. Let's turn to science. Here we have 1 negative electron plus 1 positive positron sums to 0. They meet, they emit a photon, and that's it. Now, of course, 3 negative electrons are greater than 1 negative electron, just as 3 positive positrons are greater than 1 positive positron. So if we are seeing symmetry and discerning when it breaks, it's a key for understanding both mathematics and physics. Physicists like to search for symmetry. Let's consider the Big Bang. There's even a book, The Universe from Nothing. Here we've got a Big Bang, and on this very simple diagram we've got planet negatron towards the left of your screen, and we've got planet positron on the right of your screen. Now imagine that we're halfway between those two planets of equal mass. We'll have 0 gravity acting upon us because the forces acting on us are equal and opposite. We wouldn't say that a force with a leftward direction is any less than an equal force with a rightward direction. So the ideas of Brahmagupta and ancient China start to be more closely resembling the laws of physics that we find today. So whenever opposing quantities or forces or directions are equal, you will find 0. If you sum all the numbers on the real number line, they will sum to 0. And one of the strange things is we say things that are actually pretty nonsensical. And we keep on saying it almost as if we're in a cult of mathematics. Perhaps it's no surprise that the superior mathematical foundations of ancient China and India were pretty much hidden by cultures from the West that had political, cultural, and religious motivations to assert their inferior mathematics concepts on top of indigenous mathematics around the world. So here we've got a concept I call the 0-point choice. From an arbitrary point, when you draw a line, which direction do we go? We draw a point, then we can go left, or we can go right, or up, or we can go down. But what we can start to realize is that one of the problems in the evolution of the mathematics foundations is we missed the existence of negative geometry. Here we have the start of the Cartesian plane. This is René Descartes' diagram from his La Géométrie. And this describes multiplication for the first time, not as an area model, but as line segments via similar triangles. And what we can do, though, is we can, all of these magnitudes in geometry from Euclid right through to pretty much modern day, the line segments were just line segments. They weren't positive, they were just lines. But what we can do is we can extend lines onto the other sides of what I call an origin point, a 0 point. So if we do that, a whole lot of new geometry appears with negative and positive magnitudes. So here's the same diagram. And here we can just apply the GeoGebra applet. We can drag the multiplicand onto the other side of its origin. We can drag the multiplier onto the other side of its origin. and via the property of the model, we see that the product is positive. So here we've got two negative magnitudes generating a positive magnitude via the original diagram from René Descartes back in 1637. We also can have ideas from ancient Egypt that led to geometry because of the flooding of the Nile, and the farmers would lose their land, so they'd have to measure the area of their land to calculate how much taxes they would have to pay. So geometry, or earth measurement, never had a system of negative and positive magnitudes applied to it. But what we can say is that if the fishermen, they cast their nets on the surface of the Nile, when the Nile flooded, that was good for the fishermen, and it was negative for the farmers. When the Nile was in drought, that would be negative for the fishermen, it would be positive for the farmers. So we could have seen a natural system of area models of positive and negative geometries emerge from Egypt, as the story goes, when Thales visited and took the geometry of ancient Egypt back to Greece through his ideas of similar triangles. But a lot of, Aristotle stuffed it up because Aristotle said geometry and number must always be kept separate. So Thales was fantastic, but then the mathematics started to go into decline because of the separation of arithmos from arithmoi. Refer to that background paper. So let me say that numbers count or measure quantities and actions, and our universe is made of matter and energy. And the least quantity of matter or energy you can have is 0. So therefore, negative numbers cannot represent quantities of matter or energy less than 0. You cannot have a negative number of actions. The least number of actions you can have is 0. So a negative multiplier has nothing to do with being less than 0. We'll see that in a few moments. And let's, in the model that follows, let liquid cubes or wholes be negative. Here we've got an algorithm for multiplication which you're probably not familiar with because of the shockingly bad evolution of elementary mathematics. But negative a multiplied by plus b equals negative a added to 0 b times. So the plus sign in front of the multiplier refers to the number of times the multiplicand is added to 0. If we had negative 3 multiplied by plus 2, note the language, that equals negative 3 added to 0 2 times. 0 plus negative 3 plus negative 3. Or in our model, 0 plus 3 wholes plus 3 wholes. And that means that ocean level 0 plus 6 wholes, or 6 liquid cubes. Now let's consider negative a multiplied by minus b. For the first time, you're starting to get the correct grammar of the algorithm. So negative a multiplied by minus b is negative a subtracted from 0 b times. So the dash in front of the b is not a negative, an adjective, it's actually a verb, an adverb, the multiplier, where it talks about subtraction. So if we've got negative 3 multiplied by minus 2, that passes as negative 3 subtracted from 0 2 times. So that's 0 minus negative 3 minus negative 3, or in our model, 0 minus 3 wholes and minus another 3 wholes. So that means ocean level 0 minus 6 wholes, or 6 liquid cubes. Here we've got ocean level 0. We've got 10 bricks and 10 wholes. So we've split our 0 into 10 positives and 10 negatives. 0 minus the 6 wholes, or the 6 liquid cubes, means that we see that 6 of those black holes have been removed. So we note that the 4 positives and the 4 negatives will sum to 0, which means 0 minus 6 holes, or 6 liquid cubes, results in or leads to 6 solid cubes. This is very simple ideas of physics in action in our model. So 0 minus negative 6 equals positive 6. We start to see the symmetry, and what we can see here, that this is a consequence of the definition of 0, because we can transform this to 0 equals positive 6 plus negative 6. So here are Brahmagupta's 18 Sutras of Symmetry, and if you pause this later on, you'll see that the word 0 appears many times. And as you can also see, if you're interested, I've provided the original Sanskrit for Sanskritists or people in India who may be curious. So here in particular is Addition Sutra number 4. When positive and negative are equal, the sum is 0. Now, India and China never said anything as absurd as, by definition, negatives are less than positives. That's just a consequence of the haphazard way our mathematics pedagogies arrived to our classrooms today. And I've tracked down all of the history behind where mathematics went wrong throughout history. So here we have a 0. We've got 1 positive and we have 1 negative. Here we have another 0. We've got 2 negatives and we've got 2 positives, now conveniently labelled. So 0 minus 2 positives simply leaves 2 negatives. And here we've got 0 again, as 2 negatives and 2 positives. So 0 minus the 2 negatives leaves 2 positives. So we start to have very simple ideograms available to us where we can explain mathematics visually with the correct logical foundations. So we know that negative a multiplied by minus b equals negative a subtracted from 0b times. So negative 1 multiplied by minus 1 equals negative 1 subtracted from 0 1 time. So it's not negative multiplied by negative, it's not minus multiplied by minus. We've had all sorts of amusing anecdotes. Minus times minus results in a plus. The reason for this we must not discuss, and so on. But I am discussing it, and I'm hoping that you get the point. We have not yet had the elementary foundations of mathematics explained correctly to us. Here we have a 0. We have 1 negative, we have 1 positive. So from our understanding of how integer multiplication works via the principles of ancient China and ancient India, negative 1 multiplied by minus 1 is negative 1 subtracted from 0 1 time, and there we've got it. That's negative 1 subtracted from 0 1 time results in 1 positive, or positive 1. Negative 1 multiplied by minus 1 equals positive 1. It's a consequence of the definition of 0. Now, unfortunately, to say that we define negative 1 multiplied by negative 1 equals positive 1 to preserve the distributive property of multiplication is inane. There are no negative terms in a minus b multiplied by c minus d. They're just positive terms being subtracted. I go into detail on this matter and the history in lots of detail in various papers that I've written. So let's have a look at this reality check from our physical foundations. We've got 12 positives and we want to subtract 4 negatives. Well, 12 positives minus 4 negatives is actually impossible. We don't have any negatives to subtract. So that should be the first thing that you want your students to notice. We don't want to apply silly laws like 2 minuses make a plus. And I hope that you've noticed that for adjectival signs, I use superscript symbols, and for verbs, the operations, I use standard case symbols. So we can read this more easily as positive 12 minus negative 4. Now, we don't have any negatives to subtract, so we have to add the identity element 0, and in this case we'll add it in the form of 4 positives and 4 negatives. Now, we know from our Brahmagupta's 18 Sutras of Symmetry that when we add 0 to any number, it doesn't change that number. So we're not changing the number by adding 0, but it becomes a power tool for us to apply. So therefore, by adding a 0, we have positive 12 plus positive 4 plus negative 4 minus negative 4. Well, we have the negative 4s just cancel out now, and that results in positive 16 or 16 positives. So here, again, are Brahmagupta's 5 addition sutras. And again, addition sutra number 4 is the key. Adding 0 is a simple power tool. And so why would Brahmagupta go to such trouble to talk about positive plus 0, negative plus 0, 0 plus 0? He wants us to apply that additive and subtractive identity element to our system of mathematics, our zero-based system of mathematics. So this is in the background paper and slideshow, but I'm also going to mention it here to amuse you perhaps. So here we've got how to reveal 2 minus 5 to 7-year-olds. Now, the first thing that you might expect your students to say is you can't subtract 5 of something from 2 of something, and they would be right. So here we've got Podo the puppy, and Podo is calling out, "Bricks for sale, buy your bricks." And along comes Zaki and says, "I want 5 bricks, please." "I don't have enough bricks. Please come back later." "Okay." "I have to add 0, thinks Podo the puppy, because Podo the puppy is very clever. And if you've ever played with a bucket and spade, you'll enjoy reading these stories. So, in India, children play the happy Harappan positive brick and negative hole game. So Podo the puppy has added a 0 in the form of 3 bricks and 3 holes. So Zaki can come back, take away his 5 bricks, and now Podo can call out, "Holes for sale." Now, here's maybe an exercise for you to do later. If somebody wanted to come and buy 5 holes, what would Podo the puppy do? She would dig 2 more holes, also making 2 bricks. Then the 5 holes can be used to fill up, to use as wells or put rubbish in. Doesn't matter. We can play the game across negatives and positives. So here's Podo the puppy with 10 bricks and 10 holes, all summing to 0. So now we turn to the law of 0. And the law of 0 is what we do to 0 to make an addend, that we do to the augend to make a sum. So we've got the augend, which is the first term in addition, by the way, and we add an addend. So we started off with 0 for the addend. We've got nothing there. We add 2 to the addend, so therefore we must add 2 to the augend, and that creates the sum. Now, I'm being careful here to follow the principle of mass conservation. So the most we can ever have in our little model here is 5. Usually people would do 3 plus 2 equals 5, but we're somehow showing then we've got 10, which is not how our brains want to process logical ideas. The law of conservation of matter, as I just mentioned, we can't duplicate quantities in the expression. The most we should see in 3 plus 2 is 5. So we've got the augend plus the addend equals the sum. And what have we done? For every operation, there's an equal and opposite operation. We have actually subtracted 5 from the left-hand side, and we have added 5 on the right-hand side. So how's that for a beautiful application of Newton's third law with the laws of podometric? So there we've got the org end of 3 and the add end of 2, and they become the sum of 5. So here we've got some simple schematics that will help you play with this idea of the law of 0. So what we do to 0 to make our B, that we do to A to make our C. That was for addition. Now we have the law of 0 for subtraction. And this is based on observing simple ideas, the simplest ideas of physics in our model. So we've got the law of 0 for subtraction is what we do to the subtrahend to make 0, that we do to the minuend to make a difference. So we've got the minuend, and then we have a subtrahend. So we have to make the subtrahend a 0. So we take it away. It's gone. And so we have to do that to the minuend as well. We have to take 2 away, and boom, that's the difference. Now, under the principle of conservation of mass, somewhere else, there were actually 2 were added, and I'll give you an idea of that. Here, we've got 4 cows in a paddock, and we've got a truck. So if we subtract one of the cows from the paddock, the law of conservation of mass, or Newton's third law as applied to operations, we've got 1 subtracted matched in our model with 1 added. It's amazing how mathematics starts to become very simple when you start to realize the symmetry of the operations and the laws of mathematics documented by Brahmagupta in 628. So we've got the law of 0 for subtraction. When we subtract B to make our 0, then we repeat on A, so C is our hero. And I'm whizzing through very quickly, I know. You'll be able to watch this and slow it down. And if you want any of these handouts, you'll be able to download the PowerPoint presentation from the web address given at the start of this presentation. So here's the law of 0 for 2 negatives minus 4 negatives. Whoa, that's really hard to get our head around. But applying the law of 0 based on physical properties of matter means we want to make those 4 negatives a 0. That's what the law of 0 for subtraction is all about. So we add 4 positives to make the 4 negatives 0. So we've done that to the subtrahend to make a 0, because 4 negatives and 4 positives are 0. So now we do that to the minuend. We add 4 positives to the minuend, and then we see that the difference then becomes 2 positive. I'm running out of time, so I'll whiz through these slides reasonably briskly. We've got the law of 1 for multiplication. Now we've got these, I'm just mentioning now, we've got these laws of the identity elements, 0 and 1, that you're not familiar with. And the reason is that Western mathematics, for most of its history, did not consider 0 or 1 to be numbers. And the first book printed on mathematics, the Treviso Arithmetic, actually said numbers start at 2. So that is actually because of arithmoi. That's because of philosophy. So if we switch to arithmos, of course, 0 is a sum of equal positive and negative numbers. So the law of 1 for multiplication, what we do to 1 to make a multiplier, that we do to the multiplicand to make a product. So we start to get the correct ideas of proportion entering into our ideas of multiplication and division. So we've got our multiplicand multiplied by multiplier equals a product. So we've got the unit 1. And if we've got a multiplier of 2 and our multiplicand is 2, then just as 1 became 2, 2 becomes 4. So the law of 1 for multiplication, multiplying can be fun, use C, do to A as 1 made B. So here we've got what I call a multi-mat. So we've got a unit 1. So as 1 becomes 2, so 3 becomes 6. One thing which is always fun to do is to sing. So I've got the podometic multiplayer song. Multiplying can be fun, you see. Do 2A as 1 made B. Division, you see, is lots of fun. Do 2A as B made 1. Multiplying can be fun, you see. Do 2A as 1 made B. Here we've got those the multi-mat and also the divi-mat. And you can start to play with your ideas of proportion as 1 is to B, A is to C for multiplication, and for division as B is to 1, A is to C. I hope that you've enjoyed this brief introduction to how science can simplify and supercharge our learning and teaching of primary level mathematics. This is just a sampler. I've been giving many lectures in India and to people in Europe and now in North America, and I'm delighted to be able to say that I'm going to be a keynote speaker at the NCTM annual conference in LA next year, where I'll also be discussing these ideas through a historical lens of why these simpler ideas of the foundations of mathematics, these symmetric ideas, failed to emerge. We've had a 500-year period where, from the first book of mathematics printed in England, there's been almost no change to our basic understanding of mathematics, largely because of the rule of the philosophers of ancient Greece and the cultural suppression of the superior scientific empirical mathematics foundations of ancient China and India. So thank you for watching. I've really enjoyed putting this presentation together. Stay safe, stay happy, and I'll see you soon. And if you've got any questions, please feel welcome to ask. Thank you.